So as we start getting ready for our Quadratics unit test here, this first part, we're going to do a little bit of a review. I'm going to try to reference some of the help sheets as we go along, too, if I can still locate them with the number that I've passed out to everybody here. We'll see if I've got any of those left still. But here, okay, sketch the graph of the function. Name the vertex, the domain, the range, and if it's a minimum or maximum. Hint, x equals negative b over 2a when using standard form. Okay, so for numbers 1 and 2, they're in standard form. Standard form just means there's no parentheses there. So, what I would want to do here is I would want to know what my A, what my B, and what my C values are. Why? Because that's how I'm going to find my vertex. So, let's see here. So, x is going to be the opposite of b. So the opposite of 12 is negative 12 over 2 times a. And we've talked before about how if I go to the calculator on this, it can get me into trouble. Because if you just typed it in the way I have it up there right now, you're not going to get the right answer. What? Then why'd you write it up there that way? To get you to think. First of all, I really don't think you need a calculator to do 2 times negative 2. And I really don't think you need a calculator to do negative 12 divided by negative 4. But again, if you decide that's a comfort level that you need, okay, what you're going to need to do is you're going to need to make sure when you do your division that you're putting that stuff, the 2 times negative 2, in parentheses down below. Ooh, clear. Okay, to make sure you get the right answer. If you don't, like I said, it won't work. You're like, okay, that's x. What about y? Take the 3, plug them in. Now that you absolutely could go ahead and type into the calculator. I'm trying to find a spot where I'm not going to get a glare. Oh, good job, Harty. You picked the worst spot in the world. All right. So negative 2 times 3 squared plus 12 times 3 minus 20. Okay, so negative 2 is my y value. So my vertex, let me come back over here, is at 3, negative 2. So 3, negative 2. Now at this point, we've talked about a couple of ways I can get my other values. We've talked about a pattern, and we've talked about going to the chart on the calculator. Most of you going to the chart is probably going to be your best method of tackling this. So if I'm going to do the chart, I'm going to go ahead. I'm going to plug in my values that both go to the left and right. But here's going to be my big thing. Besides, I'm going to gamble right in the middle of doing this. This ought to be good. Oh, dear. Blackout. Wait. We're recovering slowly. No, that's not going to get it done. Like, really, dude? You couldn't have figured this out before you started doing a video? Nah, it's no fun. So, we will type as it comes back into play here. We'll get our equation typed in. And we're going to do second graph because we want the chart. So what I'm going to notice, okay, remember where my vertex was, 3, negative 2. This is going to be my way of double checking. Because I should see 3, negative 2 in my chart. And I do. And so now I can fill in the other values once I have that. Because I notice at 2 and 4, the y value is negative 4. And I notice at 1 and 5, the y value is negative 10. Which is good, because I should see symmetry. So once I have those, I can go ahead and plot my graph. Now, if you want a method that goes a little bit quicker, okay, if you want to use that, that's fine. Remember, though, whenever I see my A value, that's kind of my air quote slope. And we've talked before about the +1, +3 pattern, but you'd multiply it by any A, so that'd be 1 times 2 would be -2. You go down 2 and over 1 each direction. And then 2 times 3, -2 times 3 is -6. I'd go down 1, 2, 3, 4, 5, 6, and over 1. 1, 2, 3, 4, 5, 6, and over 1 in each direction. But the calculator does the same thing for me. However you want to roll is A-okay. So let's see. We named the vertex. We still got to do domain and range here. I guess we're going to do that over here. Remember, with parabolas, my domain is easy. This is not only going down, it's also going out. It's also going left forever. And this is not only going down, it's going out to the right forever. Your domain on every single parabola you ever graph, that's the domain. That's the no-brainer. So then here, my range. Now, it goes down forever. I got that part down. But it doesn't go up forever. It only goes to here, which is -2. And then our max and min stuff. If my vertex is on top of the hill, it's a max. If my parabola was going and I had a valley instead of a hill, that's what a minimum is going to be. And that's what we're looking for on these. There's more work to doing the standard form ones than the vertex form ones, which we're about to see here. But that's what we'd apply over to number 1 if you haven't taken a peek at any of these yet. So as we move towards number 4, life gets a little bit easier, because I can take my vertex straight from here. Why is that? Because my vertex is H and K. So my vertex is the opposite of what I see in the parentheses. And then whatever's on the outside. So that'll help me a little bit. When it comes to making my chart, again, I can use the pattern if I want to, but otherwise, I can go pattern, I can go chart. I like the idea that I've got options here. So let me get that where I can see it. So we'll get that typed in. I'll hold this to get my glare off. Pull up my chart. Now again, I want to get the -2 towards the middle, because I want to see first, did it match up? Yep. And second, do I see symmetry? And I do. I see 6s in both the next numbers and 12s in the number outside of that. So once I have that, I can get those plotted, get my curve in. Not too bad. And now I just get all my other info. My domain, don't even have to think, don't have to look at the graph. Forever left, forever right, forever right, not forever light. Okay. Now my range this time, I do have to think a little more. It's going up forever, and we always go bottom to top. So do not put positive infinity as your first value, because that will never be the bottom. The bottom, again, we're looking at y's when we're looking at range, starts at 4 and then goes upward. And since my vertex is at the bottom of a valley this time, that represents a minimum. Okay? So lots of little pieces, but the biggest thing is just going to be get the vertex and then let the calculator help you. Okay? And yes, the hint will be on there tomorrow as Well, either on the test or on the board. I will give some assistance with that. So you've got me on tape saying that now, so I can't back out. All right. So as we flip over, solve each equation by factoring. And I'm going to do this as we go as well. Those first questions, there's going to be one standard form and one vertex question on the test tomorrow. Okay. When we're doing solving by factoring, there will be 2 solving by factoring questions on the test tomorrow. So when it says by factoring, yes, you have to factor. Do not just plug numbers in, random numbers. That's not what we're looking for here. So here, looks like a diamond. If need be, you can bust out your factoring help sheet. Absolutely usable. So I look and I go, okay, I need to multiply to a negative. I'm also adding to a negative, means my negative number is bigger. And I'm doing the wrong problem. Oh, that's okay. So, multiplying to 6 and they're 5 apart is 6 and 1. Don't stop. Oh, no, don't do it. You're going to take each set of parentheses that has an n. You're going to set them equal to 0. And then you're going to solve them. Okay, now unlike the radical questions, I do not need to check them, because I'm not going to have restrictions. So we just solve it. Here we go. Now, I'm going to assume that a lot of you, the minute you see number 6, are going to think, oop, I got to slide and divide. Do I? If I follow my golden rule, which is on every single question, is there something they all have in common or something that divides in, it is worth your while, if you can ever avoid the glare, oh, it's this side this time, okay, to take each of the values there and see, hey, does that first number or any number divide in? Well, hey, 4 goes into everything. Okay, so the 4 gets to tuck on the outside here. 36 divided by 4 was 9. 80 divided by 4 was 20. And now, when I go to factor, I'm just factoring what's in the parentheses. It's like a diamond problem now. Doesn't mean the 4 disappears. It just means, as far as the factoring goes, I'm just using this. Multiplies to a positive. Both my numbers could be positive, both of them could be negative. Well, how do I know? This tells me they're both negative. So I need 2 numbers that multiply to 20, but since they're the same sign, they're going to add to 9. 5 and 4. And let me give a word of advice, because I know how some of you have been thinking with these. I've seen them. Okay, this is not a slide and divide. Do not divide those by 4. Okay? That only happens when it's still stuck to my squared term. So here, I'm going to take each of the sets of parentheses, set them equal to 0. Not the 4. If there was a b with it, yes. If there's a variable with it, yes, but not if it's just by itself. And I'm going to get my answers. Okay. Now, could I do slide and divide and still get to the answers on this? Yes, but man, those numbers are going to be big. I don't want you to have to get stuck doing that. Okay. Number 7, I'm not going to do, since I did number 5 already, silly of me. But I am going to say this. You have to make sure that you have equals 0 before you start. In other words, here, that's not anything equals 0. There's stuff on both sides. You want everything on the squared side. Do not minus the b squared. That makes this a whole lot more tough than it needs to be. We need to move the 8 with an opposite. We need to move the 6v with an opposite. So I get equals 0. And then write them in order from the largest exponent, the largest degree, to the least. Now it's just a normal diamond problem. I can go ahead and do it like I normally would. But I want you to be aware of that. You may have to adjust your problem a little bit before you can start solving it. So just, like I said, just be aware. But I'm not going to finish that one. I'm leaving that one on you. And 8 will be the same way. Now 9, okay, 9 I always look, I'm like, okay, I got to see if something divides in first. Hey, 2 goes into 2 and 20. I'll just divide those two. No. It's all or nothing. And since 2 doesn't evenly go into 13, I get a decimal. I've got to deal with this. So I'm either going to guess and check, or what has become some of yours favorites, at least you do the slide part, is to slide and divide. So that 2 goes down to the end. Now it just looks like a diamond, and we're going to treat it as such. And I go through looking for my hints. Multiplies to a positive, which means both positive, both negative. How do I know? I'll look at the sign in the middle. So now I need 2 numbers that multiply to 40. But since it's the same sign, I'm going to add to 13. And so I start dividing numbers in, and I'm going along. Oop, there it is. Okay, there's my one that gets me to 13. But here's where, again, and I've written this on so many quizzes this year, I'm going to say it here to hopefully avoid it some more. Do not set those parentheses equal to 0. It's called slide and divide for a reason. We haven't divided yet. Got to do the dividing part. If it goes in nice, that's great. If it doesn't go in nice, in other words, if you get a decimal, if you're like, all right, 5 divided by 2, no, that's no good. Math, enter, enter. Okay, and it's still, whoops, and it's still 5 over 2. That just means this guy's going to slip to the front. That gets me to my value. And now I can take each of those sets of parentheses. Get to my equals 0. And solve them. Again, add my 5 over. And if you go to a decimal answer there, I'm not going to scream. I'm going to probably have 5 halves on mine. But if you had 2.5, that'd be okay. And so you do that exact same thing on number 10. Okay, same process. Just kind of work through there to get that where you need it to be. Okay, so again, there's going to be 2 of these type on there, which means, ooh, it's not going to be all 3 of the different things he just showed us. Nope, only 2 of them. But you got to be ready for all of them. Okay, next section, solving by square roots. Let's see here. Looks like we've got a couple of those as well. But I didn't mark 11 and 12, which means my ones I'm doing must be on the next page. Yes. Okay. So 13 and 14. First job. Okay, I'm going to work on getting this alone. I could distribute here, but that's usually not a good idea. So I'm going to work on getting this other stuff out of there. So again, my first goal is to get the parentheses by themselves. Oops, 172. So since I'm trying to get this part by itself, I'm multiplying it by 4, so I'll divide. Now, here's where I've got to talk about there's a difference with things. Here, I've got a set of parentheses. I'm actually going to go backwards after we do this one. But there's no squared outside. Okay, we're going to do one with the squared outside in a minute. If the squared's not outside, those parentheses can just go away at this point. And now I can just work on getting to my x squared. And I would say probably at this point the only thing left that could mess you up is if you forget the one little detail that remains. Okay, square root of 9 is a perfect square root of 9. Well, it is too. Square root of 49 is a perfect square. It's 7. What? Yes, plus minus, okay? Squared means there's 2 answers. And I got to get them both. So if I just put 7, I'm missing one of my answers. So when you're doing these, that's our big thing. If the squared is on your x, your sole idea is to get that x squared alone and then square root. Do not square root before. Not up here, not up here. Once x squared is by itself. Unless, anyway, I gotta say unless. Unless we get a problem like 12. Sorry for my flippage here, but I want to make sure we get the right thing. Here, if the squared's outside, my first job is to get that alone. So since I'm multiplying it by 5, we divide. But here, this is a little different. My b is trapped in the parentheses this time because the squared's blocking me from getting rid of it. This is the one time when doing the square before the last step is the correct way to do it. Squared and square root would cancel, just leaving me with the b plus 1. Square root of 16, again, happens to be a perfect square here. If it wasn't, I'd attempt to break it down. We'll be doing some breakdown here in a minute. And I got to remember my plus minus. Okay, so this test is going to be a lot about details. But doesn't math always seem to be that way anyway? So here, I'm not just going to minus 1 and call this plus or minus 3. That would be okay with one answer, but it's not going to work for both. So here, if this was a radical instead of just being 4, I'd be done. Like if this was the square root of 3, I'd be done. But since it broke down, I can actually find out what negative 1 minus 4 is. I can find out what negative 1 minus 4 is going to be and actually get to the answers. If it's a radical, again, you can leave it. If it breaks down, you need to break it down. But if there's a radical, it just stays at the plus minus. Otherwise, we get those values and we work through those. Get those set. So, again, not too shabby. Just got to take my time. So, again, there's going to be 2 of these on the test. I'd imagine there's going to be one with the parentheses like this, and then one where you're just getting the squared term alone and then square rooting, because that seems like a smart thing to do. All right, let's see what else we got here. Simplify. No decimals. So what's Harty mean? Harty means if I punch in the square root of 108, I don't want to see your answer as 10.39 or 10.4. Okay? What we're getting at here is that we need to either know our cubes or bust our help sheet back out and find the biggest perfect square that goes in. Stressing biggest. So you start dividing these numbers into 108 until you find one that works out nicely for you. Well, I'll be your human calculator here. The biggest one you're going to get is 36. Okay. There are others that would go in. 9 and 4 would both go in, but they're not the biggest. And one will break down, and one won't. Notice, no plus minus. Okay, this isn't a quadratic formula. This is just breaking down a radical. Break it down, you're done. So again, that one I won't say as much about. That's helping you more for some other problems when we're getting on there. All right, solve by completing the square. There's going to be 2 of these. This is where you've got your help sheet from before. The one that's got, because somebody took my last one the other day, at least that I had up here. Or if need be, these are still over sitting there too. This will verbally kind of take you through it. You're like, okay, what do you mean? All right, let's look. Okay, do I need to divide? No. X is alone. Okay, well, in this case, it's K's. So K's need to be alone. And again, the little help sheets here still available over in front of the folders if you need them. I need to find B. Okay, remember, when we're in standard form, number in front of squared is A, B, C. So my B is negative 14. Well, what do I do with it? Here we go. We need to have B. You need to square half B. In parentheses, of course. You need to add it here. You need to add it there. That's why we put the blanks in. Once I do this, I'm going to factor this, but we talked over and over about how I can do this quickly. they're always going to become the square of a binomial. Well, how do I know what to put in here? Well, the easiest way is to say it's half a b, or it's the number in parentheses if I did my side work. Simplify what's on the other side, and now it looks, solve the square root, plus minus is key. Solve for x. Easy, you see. Now it's just like the problems we just got done with. I got to get the squared out of there. K minus 7. Square root of 81 is 9 with my plus minus. The 2 tells me how many answers there are, but so does the help sheet. And I add my 7 to get k by itself. And again here, if it would have been a radical, I just leave it alone. If it's not a radical, I go ahead and simplify both. And that's what my completing the square does. Now the steps, the have, b, square it, and add it here, add it there, that works for all of our versions of completing the square. I mention that because we've still got more of this coming. Okay, complete the square twice to transform the equation from conic to standard form. Okay, when we're dealing with circles, this is the form we're trying to get to at the end. And again, this is another help sheet that's floating around out there, hopefully in your folder still. Mine I gave away yesterday, but I do see there's more over there, so I'm going to grab one quick. So here, I'm still going to get my x's together, my y's together, and I'm going to do my little form that I did before. I'd forgotten there was help sheets even for graphing parabolas. That's over there too. Shoot, this is great. Okay, so circle. Okay, there's my form. X's together, Y's together. All right, so X's together with a blank. Y's together, keep your signs with a blank. And get any number that isn't a variable. That would be 268. It needs to go bye-bye, but it has to be an opposite to move it. With both blanks. Because now what I'm going to do is I'm going to do a little bit of side work. I'm going to come over here. I'm going to go, all right, 8 divided by 2 is 4. 4 squared is 16. I get those in. I do my side work for y. Negative 32 divided by 2 is negative 16. Squared is 256. And so now, especially if I've just done that completing the square problem up above, half of b, the number in the parentheses, positive 4. Half b, the number in parentheses for my y, negative 16. And add those guys up, and I am in standard form. Okay, it doesn't take long. I just got to use my sheet to kind of help me out to get there with it. Okay, so that's the exact same thing I'm going to do on 20, to the t. And we'll have you set there. So I got one more completing the square. There's going to be one of these coming at you here. Get the equation in vertex form. Okay. Vertex form. Looks like I'm going to have a blank on the y side. Looks like I'm going to group my b's. Have a blank with those. And otherwise, it's the same thing. Take my b. Have it. Square it. But now, the form I'm trying to get to is vertex form. So I'm looking at this and I'm like, okay, so this has got to be squared. Oh yeah, it's just my half b. So then I look at it again and I'm like, ooh, but it's just plain old y equals. So to get y by itself, I stay outside my parentheses. But this time it says, name the vertex. Opposite of h plus k. And get to my answer. And so as I finish up on some of the rest of these, okay, again, the quadratic formula, it will be up on a board. So since it's going to be up on a board, I'm just going to start working it here. Again, make sure, please, that you're at equals 0. That's important. If it's not, you would need to minus your 80 over, whatever value it happens to be first. And then we do the opposite of b. The opposite of negative 5 is 5. Plus or minus the square root of b squared minus 4ac all over 2a. And we've spoken before about how we want to take this part on the inside. We want to type it in without necessarily having the radical. Because we've said before, I want to know what this number actually is in case it's not a nice perfect square. 121 and 2 times 4 is 8. That's one big fraction. If I'm not sure, I try the square root of 120. Oh, that came out nice. Well, isn't that helpful? And again, this is one of those, if you left it there, you're going to lose a little, but it's not anything terrible. I am noticing that I may have to finish off some of the rest of this later in post, because we might be slightly pressed here. 16 divided by 8 is 2. Ooh, now this one. 5 minus 11 divided by 8. I guess the decimal would be okay, but I like going in fractions, so negative 3/4. And we're set there. Let's see. Let's kind of keep playing here. Okay, simplify. Treat I just like you would any variable. So distribute the negative all the way through. And here I'm just going to combine like terms. Negative 3 minus 4 is negative 7. Minus 3 is negative 10. Get to my answer. That's different from when there's nothing in between. Those are the ones we got to box or FOIL out. So for instance, if I have this guy, and again, we'll have one problem like this, one with the multiplying tomorrow. You can go through just like you have before and do old-fashioned FOIL if that works better for you. If not, and you do a box, we're just multiplying the edges together. And anytime I see I squared, that's going to be negative 1, which means this is negative 4 times negative 1, which would be negative 4. So what's that mean to me when I go to simplify it? Well, 4 minus 4 is 0. So, okay, my constant term's gone. But 4i plus 4i would be 8i. And I'd be done with that. Okay? So I squared being negative 1 is really the only time we don't treat I just like we would x or any other variable. See other fun stuff back here. Oh, I always see fun stuff. I'm going to come down here to 32 for right now because I am going to make sure the stuff that's been tricky and it caused us issues on the last quiz gets taken care of here. Okay, 32. Let me stress this. We're not changing signs on both of these. We look at the denominator and we change the sign of the I when I'm doing this. And I do the same to the numerator and denominator. I don't do 1 to 1 and 1 to the other. Once I get here, I've got to box or FOIL each of these. Okay, don't go distributing happy on me here. In the numerator, when I multiply through these two, it's okay to have I in the numerator, and we will. 21 plus 3 is 24. 7 minus 9 is negative 2i. But when I do the denominator one, I should not have i's left. Like I said, I will post the other ones that I have dotted here by early this afternoon, so you can kind of see what's going on there if you need that extra. Or the whole key will be posted online, so if you need to see the key, you could. Negative 9 times negative 1 is positive 9. 1 plus 9 is 10. 3i and negative 3i cancel. That's good. And the only thing left I might have to do here is if a number divides into all three of these, not 2 out of 3, not 1 out of 3, all three, divisible by 2, 2, 2, that is one thing I can do. So as we move to number 34, okay, let me get the calculator out of the way for a minute here. Solve each equation. Remember to check for extraneous solutions. Now remember, most of the time, well, almost all the time, extraneous solutions are going to be when we have two answers and we need to check for something like that. So as far as the test itself goes, again, we're just going to have a couple of these that we're playing with. So my first job is going to be to isolate my radical. Thank you. So, if it's already isolated, great. We'll start by squaring both sides. So in a situation like 35 or 36, that's what I would do first. But here, I'm going to get that 5 out of there first. And get that on here. And once I do that, then I'm ready to square both sides. On this side, the squared and the square root's going to cancel. Scooch this over a little more here. But on this side, there is no radical. That isn't going to come out just 4. That's 4 squared. That's 4 times 4, or 16. And now I can start working through this. So as we do, so my next job is to get my 3x by itself. I'm going to add our 2 and divide by 3. And again, most of the time with one solution, you're not going to be in any danger. So we'll just go ahead and we'll leave that way. Now, if you get into a situation, let's say, like number 36. You're like, okay, good first sign here. Radical's on a side by itself. So we're going to go ahead and square. Here's an issue that came up on our last quiz that I want to help some of you avoid this time. Squared and square root cancel. But here again, there is no radical over the x. That's not just x. That's x squared. So whenever I have a situation where there's an x squared, I want all of my terms on the x squared side. That does not mean I want to minus x squared. That makes factoring too hard. So what I want to do instead is I want to go ahead and get my other terms, so I have equals 0 here, to the x squared side. And once I've done that, now I have a choice. I can either factor it, or I can use the quadratic formula. So, I'm going to go ahead and factor it. It looks like a diamond. I think I can knock this out pretty quick. So let's see here. We're going to multiply to get a negative 6. So I know it's one of each sign. We're going to add to get a positive 1, which means the positive number is bigger. So 3 and 2 multiply to negative 6 and add up to positive 1. And then I take each of those sets of parentheses, quantities with my x values. Now, are they both going to work? No, I'm being told. So we'll test this out quick. Okay, again, it's the original problem. The square root of 6 minus x equals x is what I'm plugging into. So if I do that with 2, I got the square root of 6 minus 2 equals 2. Does the square root of 4 equal 2? Yeah, it does. Okay, 2 worked. Now for negative 3, 6 minus negative 3 equals negative 3. Minus the negative is plus. So is the square root of 9 equal negative 3? Not so much. Could both answers work? Yes. Will both answers work? That's a different story. Don't know. Depends. So that's what we're going to be looking at as far as that goes. Okay. But always, it's not a bad idea to check something like that. And there's going to be a couple of these sitting there tomorrow on the test as well. Now, as we move to the back, this is going to be our last part. Like I said, we'll kind of swing back to the front. As we head back here, this is back a little ways when we were doing our maxes and mins and things with our parabola. So, the equation, and we get an equation, gives the height of the ball in feet above the ground at t seconds after the ball is thrown upward. How many seconds after the ball is thrown will it reach its maximum height? What is the maximum height? And I give a hint in here on how to do this. Now, it might even help a little bit. You're like, okay, I'm throwing a ball upward and it comes back down. What am I looking at? I'm trying to find the maximum value. I'm trying to find the vertex. So, there's 2 ways I can tackle this. If I'm comfortable enough with the calculator, one of my options would be to head to y equals here, type it in, I'm going to go ahead and hit graph here for a minute, just so you can kind of see what we're looking for. So there's my ball going up. I'm looking for this point right here. Okay, that's when the ball, no, I'm not. I'm looking for the max, which is way up here. You're like, well, I can't even see it. So here's one of my choices. If I can't see it, I can go to Window, and I can make my maximum bigger. I don't know, let's say 50 sounds like a good idea. Let's see if I can see it a little bit better then. Okay, now I can see it. I want to know what this is. So one way I can do it is second trace. It says right there, maximum. Okay. And what I'm going to do, sort of like when we found zeros before, is I'm going to get my little cursor guy. Let me move this up a little bit. Using my left and right arrows as close as I can to the top. And then I'm going to left, 1, 2, 3. Hit enter. And then I'm going to go right, 1, 2, 3, to get back where I started. And 1, 2, 3 more. And I'm creating these little lines that are trapping that in. And when I see the word guess, I hit enter one last time. And that funky value that I get, okay, the y value is how high. My x value is how long. Now, if some of you are like, okay, I was with you until you actually started pressing buttons on the calculator, and then I just lost you, okay? That's not the only option, and that's not something I'm going to walk you through every single step in the middle of the test tomorrow. So, here's our other choice. My other choice is to use my vertex formula, which we use when we're doing standard form from the first problem on the very front. So if I'm going to go that route, even though I am going to throw a reminder out here as we chat about this at the end, with all of our colored help sheets we've been getting, one of the ones that was in there as well for apps, hey, min or max value. Hey, look at, there's negative b over 2a. Okay. So what I can do, here's my a, here's my b, here's my c, is I can do the opposite of b over 2 times a. So let's see how this works. Negative 14 divided by, with parentheses, because I want the calculator to know I want to multiply these first. Okay, 0.4375. Now, if you went out to that many decimal points, that's fine, but we just rounded before. So that's where the 0.44 was coming from. But if you want to go the distance with it and put that in, that's fine. So then how do I find y? 2 choices. Okay, or how do I find h in this case? Because h, y is the same thing. One way I could plug this value in every place that I saw a t up here. And then I just grab my calculator and I type it in. Same thing. Okay? That's the straight algebra way to do it. That goes along with what we do when we're graphing. I think that's a good idea personally. Rather than trying to play all these calculator games, unless it's something you just pick up on quick. But again, these little guys are still over in front of the sheet too, and you could actually just follow, plug it into y equals, go about your business. Okay? So, this kind of gives us an idea of what this is going to look like. Again, doing some of the problems that aren't on here that we haven't done already is a good idea, and checking the key, but asking questions is a good thing as well.